Hello everyone, and today I'm going to show you how to solve the problem 2sum. Given an array of integers, nums, and an integer target, we want to return the indices of the two numbers such that they add up to the target. You may assume that each input would have exactly one solution, and you may not use the same element twice. Now you can return the answer in any order. So let's go into some examples. So if we have nums equals 2, 7, 11, 15, and the target's 9, then the indices will be 0 and 1 because the numbers at index 0 is 2, numbers at index 1 is going to be 7, and then 2 plus 7 is going to be 9. So this is why we return this. So for 3, 2, and 4, we have our target equals 6, which our output is going to be 1, 2, because we have 2 plus 4 is 6. And then for example 3, we're going to have nums equals 3 and 3, target 6, and then 3 and 3 refers to indices 0 and 1. So let's go ahead into two solutions. One of them is pretty slow and the other is going to be optimized. So first we can go into, let's say, a brute force solution. So yeah, you can use some sort of like two-pointer algorithm. Like for example, you could have a slow pointer and a fast pointer. So a slow pointer could be something like this and a fast pointer, and then just check every combination here. Go here, here and there, move the pointer right here. But yeah, this is the brute force solution, but notice here that we are dealing with, let's say, a triangle worth of computations. In other words, this is basically just 1/2 of a matrix. So the time complexity of the brute force, I'm just going to call it BF, but yeah, that's actually going to be O of n squared, which is going to be the worst time. Now the best time is basically in this problem if we find the target equals 9. So basically do a comparison here. But yeah, that's pretty much the best case, just O of 2 or simply just O of 1. That's the best case. Now, what can we do to actually optimize this solution? We can actually use a hash map data structure. So what is a hash map? So a hash map is basically a data structure that allows you to store some key value pairs. So if, let's say here you have some sort of this thing here, you have a dictionary, you can have a dict, and then let's say you have key and then value. Let's call it key K1 and V1. Let's call it K2 and then V2, and pretty much ... for all of these entries. So how does a hash map relate to the solution of this problem? Here's what the optimized algorithm will be like. So the optimized algorithm will consist of, checking if target minus whatever element we're currently on is in the hash map. If it's not, then we add that current element into the hash map and move on to the next index. Let's start with this first element here. So we have 2. We want to check if 9 minus 2 is in the map. Right now our map is empty, so it's kind of obvious that it isn't in the map. So let's actually add it inside the map. What makes it difficult with the hash maps though is that the only way you can actually retrieve the index or the value is through the key. So we're going to be adding the value as the key. So that would be 2, and then we're going to be adding the index as the value. So 2 is the key, and the index is going to be the value. And pretty much once we loop through all these elements, we already have a variable that keeps track of whatever index we're on. So let's go into the next one. We have 7, so 9 minus 7 is 2. Now 2 is actually in the hash map, so we're actually going to return 0 and the current index, which is going to be 0, 1. And obviously, if this was not the case, then we'd be moving on and performing all these comparisons. Now, this optimized algorithm, let's call this HM, which is short for hash map. So a hash map is useful for O of 1 retrieval. If you use something like a tree map, then this time complexity would be O of n log n. So this is why it's important that we make sure we have a hash map. So a tree map would basically shorten this to O of n log n. Because now notice here that if we use a tree map based on that, because that exists in Java, we'll be using something like this. So this is actually a balanced binary search tree. So this will actually be using something like this to make its decisions. And pretty much the height of the tree is going to be the logarithm to like the number of nodes. So this is why this is n log n, and you're essentially doing this n times at the worst case. So this is why a hash map is going to be useful. A hash map basically refers to whatever index is currently mapped into a bucket here. So 2 is currently mapped to somewhere in the hash table. So this is just allows you to access this in O of 1 time. So, and pretty much you could do this n times. So this is why the hash map will be O of n. All right, now, so here I am in the code. So we're going to be starting off with toSum. So first, what you should notice here is the return type is an integer array. Specifically, an array of size 2, where each element corresponds to the indices where the elements add up to the target value. So here's what we want to do. So we want to declare a new array, so indices, and initialize and declare. So new int, let's set it to an empty array of size 2. But yeah, now let's actually create a hash map. I already have the necessary imports up there, so here's what we can do. So map, but since map is a generic type, we can set the types to integer and integer. The values of the key should restrict the type domain of the key and the value. So the keys should only be integers, while the values should also only be integers. So, and we're just going to call it map, and then we're going to set this to a new hash map. And now what we want to do is traverse through the array. So for int I equals 0, I is going to be less than nums.length because we want to traverse through every element, and then I++. But then if we find a match, we are also going to be breaking the loop. So first, we're going to check to see if the target minus the current element is in the array. So to check if a key already exists in a hash map, we're going to be using the map.containsKey, and then we want target minus the element at the current index. And then what this is that we want to essentially return, we have indices, we have 0, that's going to be the index achieved from target minus nums I, so that's going to be map.get, and then we have target minus nums I. But then we also want to change the value of index 1 to set it equal to the current index. So indices 1 is going to be I. So that's going to be it. Otherwise, we have to add this value into the hash map and move on. So that's going to be map.put. Put is basically how you add an element to it. For the key, what we need is nums at index I, and then for the value, we need I. And that's going to be it. And I'm just going to add a break so that this thing will terminate early. And this is so we can improve our average case. And then we want to essentially return the indices. And let's try. So yeah, let's try a C. And there we go. We accept it. Let's submit it. And there we go. So yeah, that's it for this problem. I'm going to, in the next video, I'm going to show you how to implement the Fibonacci sequence with dynamic programming. Okay, never mind. So thank you guys so much for watching. If you guys enjoyed this video, be sure to leave a like and subscribe, and of course, see you guys in another video. Goodbye.